Coming out and joining us in person again. And for those online, hearing us online, thanks for tuning in and watching us. We kind of like to start things off by asking if there's any announcements or events going on that you'd like to share with the community. I know KCBC is coming up, I think, in September. Anybody else know of any other events?
Prairie Code.
Okay.
And end of September.
And fall time is also normally time for HDC, isn't it? So there's those events to keep your eye out. I know some of them are back to in-person. So yeah, cool. And I think we'll just go right into it. Have Mike Douglas speaking, and they've also sponsored through
Lenavi.
Okay, so let him say a little bit about Lenavi and kick things off.
All right, sounds good. Thanks a lot, Brian. Thanks everybody for coming. Sorry about all the technical problems, but don't worry, the most important part is here, the $200 gift card. So we won't have any technical problems. I even had Hy-Vee staple the activation code receipt onto them, so that should be good unless they got swapped, but hopefully that's all good there. All right, so yeah, thanks a lot for having me, and letting Lenavi sponsor the .NET user group. I know we've tried to be a long-time supporter of that. I got to kind of do a guest speaking last year when we sponsored, but this is kind of like the first official one for me since probably 2002 or 3. I think last year I tried to have Matt figure out when I spoke last, but it was sometime around then.
Yeah, thanks a lot for having me. And
CodeSmith tools and code generation.
Lenavi sponsor the .NET
so it's
user
been
group.
Definitely a long time.
I know we've tried to be a long time.
Been busy a lot of other places though. There, so
yeah, I got to kind of do a guest.
My name's Mike Douglas. For those of you who don't know me,
last year
I'm a solution consultant and the director of our delivery engineering at Lenavi.
One for me.
For those of you who don't know, Lenavi
probably 2000
was formerly Deliveron Consulting Services here in Omaha.
I think last year
we joined with Lenavi, and we now offer basically a wider variety of services. We still do all the custom modern app dev, Azure consulting, but we now also do more infrastructure related stuff, managed services, and hosting for our clients. So really offer the full spectrum. And as a company, we really like to out of the way there. We really like to sponsor events like this and support the community. It's really important to us there. So you can see a few other things on my list there. Won't go through them all, but feel free to reach out on Twitter for anything. I don't know if there's a place to put the slides and stuff. If you guys want the slides at the end, I can post them on Twitter and stuff there. So yeah, we'll just keep going with this. So I'm gonna try to talk about 3 main things. The first one here is just kind of the pros and cons and why microservices. I guess just real quick, show of hands, how many people are using and developing microservices today? So a few people, and I know that's up for debate, the exact definition of microservices, but yeah, no, that's great, because we'll definitely be talking about microservices, how you can implement it in .NET. I kind of call the first section of this kind of more inward facing for the microservice. So we're talking about the architecture and things like that from a .NET perspective. And then there's one chair over there, Karthik. Yeah.
Thank you.
Or I guess there's a couple up here too. I won't bite. And then what I want to talk about is the more from a multiple microservice, because that's really, I don't know if anybody that's ever done microservices have ever just made one, right? That's the whole idea of it. So talk about how they work together, how we can host it and provide a lot of services. And that's really where Azure Kubernetes or AKS comes into play. So let's first talk about why microservices. So what's the problem we're trying to solve with microservices, right? We've built applications before. But a lot of the challenges, I'd say traditionally built a lot of monolithic or, kind of larger APIs. There's been, I'd say, a tendency or, basically effort to really try to decouple more of those pieces and really have an ability to deploy those independently and really be able to make smaller changes and push those out sooner and quicker. And by doing that, then it really helps us make changes. If we have to redeploy our whole entire website every time we make one change, there's a lot of risk with that. Things can get, basically force us to do like nightly deployments, downtime. But if we can break things up into smaller pieces and deploy those, we can actually deploy hopefully more frequently and often with that. And the other thing too is by creating, smaller services and more single focus, it allows us to really focus on the business problem and not a lot of the technical ones. So you'll see that we'll really be trying to look at it more from a business perspective and solve the business problem and really not worry quite so much about technology and using DDD for that type of technique. So why is everybody not doing it right? And why is the if it's so great, why isn't everybody doing it? Well, it's not. There's a lot of challenges with microservices. Number one, it's not just the architecture when it comes to building it. It really forces changes across your industry, like cultural, that affects like people, the practices. Essentially, if you're building microservices, trying to deploy earlier and often, for organizations that are used to doing like monthly or quarterly deployments, that's a really big shift. And there's a lot of things that have to change in order to make that happen, right? Like your security team has to be on board with it. We still have to be meeting like compliance changes and those types of things. So there's a lot that has to go in play. It's not just like, oh, let's just create a small piece of code and we can just deploy it at any time. And one of the, I think, challenges too is just because we're breaking stuff up into smaller pieces doesn't necessarily mean we're decoupling it from other pieces of your application. And I'd say kind of the worst case scenario, if we try to start deploying microservices, but your application is still coupled, is creating something called the distributed monolith. And what that means is basically instead of a monolith where you just push one button and everything can deploy, you now have to push like 5 buttons and coordinate all those deployments between each other just to get a safe deployment out there. So that's a really big thing. Often you see a lot of times teams will start to create microservices and deploy them, but then they'll have to say, well, we need to put a gate in here that says if this change goes, we have to wait for this other change to go because they're related. If you're trying to solve those types of things, you're kind of solving the wrong problem, right? You want to basically make an architecture and microservices so they can be deployed independently. And that's not always easy because you have to, maybe your microservice now has to support a previous version, or the UI has to know if it's calling the new version or the old version. So there's just a lot of kind of things that go along with it. But there's definitely a lot of benefit to doing it. So I'd say as you're doing it, there's a lot of good techniques. One of them is also many times is called basically refactoring. So instead of starting with microservices, start with the monolith, and then once you have the monolith identified, you can kind of pull pieces off of it using like a strangler pattern, and then you can start building out those microservices. But so that's kind of the why. So again, it's really what you're comfortable with and really trying to do that. The other big piece too with microservices, and you're usually using more of like a trunk-based branching structure, feature flags, those types of things to really enable that more frequent deployment process. All right, so a little bit about the why now. Talking about the microservice itself, I just created this kind of idea. I wanted to kind of walk through this process just using a banking app idea. And so with that, just a couple of the requirements, like I wanted to be able to get the balance of my account, I want to be able to make a withdrawal, make a deposit, and then also getting the branching locations. I needed something kind of outside my, related to the other one. So kind of getting the branch locations out of there too. So what I wanted to do is kind of walk through from a microservices standpoint, how we can get from here to actual working code. And so the first step here was really about domain-driven design and kind of breaking that stuff up to kind of identify what are those, what is the level of microservice that we need? Because you think about a microservice being as small as you can. Well, there's really a logical way to group these. And one of the techniques is using this domain-driven design. A technique is event storming to help kind of get to that. One of the diagrams is really bounded context. So you can kind of group those entities together to kind of figure out what makes the most sense from a service perspective. So you can see the account, my main two things is the branch office and the account, right? So you can kind of group the account kind of together as one, and then the branch office as another one. You could break down the account down to like the withdrawal and the deposit, and even the get balance to separate services, but then you might be taking it just a little bit too small. So this is a good way to kind of right size how you're basically designing your service there. So the next thing is what's the architecture that we want to use to build our microservices? I don't know, one of the common techniques is hexagonal architecture, or a couple of things that have derived from that is like the onion or clean architecture. I guess anybody familiar with any of those terms? Something back there? By the way, it's really cool to be able to ask people to raise their hand again. It's really hard to do that on the online, so that was really been pretty awesome to be able to do that again. So the hexagonal architecture is really about separating your domain from the different parts. So it's really about decoupling. And so you look at here's really taking that account now and breaking that into these different pieces. So the domain part of it is right here. So this should be where our business rules are at. And what's really nice is most of the time with the layered architecture, you kind of have the front end connect to the back end, and the middle tier, and the middle tier connect to the back end from like a references standpoint. And then, but it also can lead to, basically like accidentally referencing maybe all the way to the back end from the UI, or even the UI from the back end. I mean, you wouldn't probably do circular, but a lot of times, like one downside is, let me take my entities from from the entity framework and use those in the UI, right? And you want to kind of have that separation of your data model versus what you're displaying to the users. So this is a really nice pattern. Again, it started as hexagonal, and then it's kind of turned into the clean architecture, and then also onion architecture. They're all pretty similar, but the idea is actually the opposite. So all your business logic is there. This shouldn't have any implementation code to know like what it's doing. Like from a database perspective, the account really has no idea. It just knows it needs to save data. It doesn't know how it does it or anything. And what's nice is there's a piece in the middle that helps kind of glue that together. And those are called ports. And the ports can basically abstract out the actual, this layer, and this is basically called an adapter. So again, kind of the domain is this middle piece. The ports are those connectors, if you will, between your adapter and the domain. And that's where you may have like your interfaces and do like your dependency injection, those types of things to connect those pieces together. The examples here, like the service, this notifier, and then the repository here. And then the adapters are really your actual implementation. Those can be both input and output. So on the front side, right now we're using a REST API to front our account service. But who knows, maybe we want to use GPRC, maybe there's some new way to implement APIs, or maybe we want to do it event-driven and do it off of a message queue or a service bus. We can change all that out, and as long as this piece, or as long as this implementation supports what we've defined in this port, it really doesn't matter how that information is coming in. So it provides that really nice abstraction layer, if you will. Any questions on hexagonal or clean? So I'll show you here the implementation, or an implementation. There's definitely different variations here. So what that kind of looks like then is on the domain side, here's our domain class, and then you can see there's all the different classes that support the accounts. There's ones for customers and so forth. I'll pull up the solution here in just a minute, and then I'll provide the link to this. This is an example I have here. The other thing here is the different ports. Also referred to as kind of the application code, and that's where we might have like our commands, our queries, repositories, really how the data moves from and to the domain, but not necessarily with the implementation in mind. And then the last part, they're good, there it goes, is the actual adapters, and which is also referred to as infrastructure. And it depends on if you're looking at more from the hexagonal side, ports and adapters. The clean architecture, it's more domain, application, and infrastructure. So, but the really meaning the same stuff there.
Ports will be the same project or separate project?
The what's that?
Ports. The middle part, ports?
No, the ports really could be separate. Like in this case, it's a whole separate project. Yep, yeah, good question there.
All the 3 ports. Can all the 3 ports in one project?
Oh, that's a good point. It really probably depends on the size. I mean, I think one of the things, this does add a little bit of extra layer of complexity, just having these 3 separate projects. If you're thinking about a microservice and keeping it small, I would say probably keep it all together just to kind of minimize that footprint of your microservice, because you really don't want to create something where, you know, it's not really worth the effort you're putting into it, right? If you have to put a ton of extra stuff into a microservice, then you're kind of maybe, you know, it's kind of a balance, right?
Would the decision between having them in the same project or separating them out, would that have a lot to do with how you want to deploy it, whether you want to deploy them together or separately?
It could. I think yeah, I do think though that this is still pretty tied to like what you want to do with the domain. I don't know if you'd ever like separate those. I do think this is not realistic here, where you have like the different ways you would do the implementation. To me, these would be probably more separated out into separate projects. Like in this case, you know, we may have like a repository, well, we do have a repository port, but we could have many different kinds of adapters that could all connect up to this. And essentially the code from a domain perspective and an application perspective doesn't change. I can switch from using like Dapper Entity Framework, in-memory database, Mongo, SQL, all those things. It's all really independent of those other pieces. So this, to me, you probably wouldn't have all these implementations together. These would be probably different DLLs you'd bring in based on what you want to do. And then this is the solution. Ironically, I was putting this together and I picked the kind of the bank account scenario. And this example actually is a bank account example. So I didn't choose my example because of that, but it was kind of funny that I did that. I was gonna build my own, but then like everything, right, ran out of time. So found a pretty good example here we could show in this. So, yes, that's the example here. So let's just jump into the code and look at it a little closer. No idea if it's open. Doesn't look like it. Should probably see a whole list of POC projects to view there. So here's that code from that GitHub repo. Again, we just wanted to expand out on a couple more of these projects. All right, and so again, the application side, you know, we can look at the, you know, some of the different repository implementations. So you can see that these are just the interfaces again. It's just that definition of like what needs to be implemented versus the actual implementation, which would be down in our infrastructure project there. So depending on, you know, if we're looking at it from a repository standpoint, the queries, the commands, so we can come in here and, you know, whether the interface here to execute from the register, or here's, I guess, the deposit. That was probably the better one to look at. And so you can see the deposit action or command here. Let's see. So the other thing I wanted to change or show our domain classes. Again, these are going to be really our representation of our objects that we're using throughout the domain. we have our credit and our debit, for the bank account, et cetera there. And then from an infrastructure standpoint, these are really our implementations, again, based on the different tools there. So we have the actual implementation from entities and queries and repositories. So definitely a lot to look at. And then I guess just the generic web API wrapper. And again, if you kind of remember that port, it's the REST API versus the service implementation. So you can actually come down here and actually see like the controller actions for deposit is down here in this use case. All right, so that's kind of an example of what that looks like. Looking at it again, there's a little bit of extra code that gets to be implemented, but the nice thing is our domain logic is all separated, so it makes it real great for unit testing. All right, so now we've kind of looked at like what the individual microservice looks like. Now let's kind of talk about like what does the different microservices together and how we communicate with that is. So what are some of those challenges that we have with this? We're going to talk about like some of the patterns that there are for working with multiple microservices. Some of the cross-cutting concerns that we may not want to address in every microservice, how we can actually leverage some frameworks for that, and then actually how we manage the life cycle and kind of orchestration of those services. So, just a few kind of challenges that there are here. The first one here, like APIs at scale. I think that's, to me, is really the key. If you just have one or two APIs, a lot of the problems you might be feeling really aren't as bad. But when you start scaling those out to a lot of different ones, I'd say traditionally we've done a lot around like PaaS and serverless in Azure. So we're building out a lot of Azure functions or app services, and we have ARM templates associated with those. We have to basically secure each of those and manage those deployments. If you start kind of adding up what all those things are individually, those become a lot to maintain. I don't know, like we've got some ones where we're talking about different, like the different ARM templates for each of those deployments. We even have to deploy some of the ARM templates and like get the IPs so we can put them in as whitelisting for the other IPs so we can have that kind of secured down. So there's some maintenance of each of those individually. So as you start to get to a certain number of those services, it starts to become, I think, harder to kind of manage on those. The next one, distributed tracing. So if you are trying to debug, I mean, it's one thing if you have an application on your machine, you hit the run button to debug it locally. It's not too bad when you just have one service. But if you have 15, 20, 50 microservices out there and you're trying to troubleshoot those, it can be really difficult. And so one of the challenges is being able to do something like distributed tracing. So there's some nice tools out there to help with that. The other thing is really coming again from a coupling perspective. If I have a microservice and I need to call another microservice, the one thing we want to try to avoid is really kind of connecting those two and coupling those together. So we really don't want to have to, like one microservice know the URL of another microservice, because the whole idea of having all these microservices is they're out there and we can just leverage them, and we don't need to know what the exact URL is, any port numbers. So service discovery and invocation is really important. I'll show kind of some ways that we can kind of help manage and minimize that. I touched on the security access restrictions. A lot of times we're building our applications out in the cloud. We're locking those down from an authorization standpoint and authentication standpoint. We're also locking it down from a access restriction standpoint. So the only things public are the things that the users will access, and then we try to make everything else kind of pseudo private, if you will. It's harder to do in a PaaS services, but we're trying to do that. And I'll show here in a minute with Azure Kubernetes service, that may even be deploying that privately, but then making it public through a different way. And the last one is cost too. If you're looking at let's just say an AKS implementation versus functions and paths, The functions and paths are going to be a lot cheaper when you have a few services. But if you start having quite a few of those and you have maybe an app service plan for each of them, that cost can creep up there, whereas the AKS cost is kind of the same. Eventually you have to add more nodes to your AKS cluster to run more services, but it's much more of a gradual, like a cost per application will go down, essentially the more applications you put on there, whereas app services will basically go up with that. So some of the patterns that we're going to look at, this is just kind of a walkthrough of some microservices patterns. We'll go into each of these in a little more detail here. The first one's API gateway. So the API gateway pattern is really nice from a microservices standpoint and communicating, because really, especially from like a client application, there's only one endpoint then for it to go. And it really makes it a lot less chatty. So if you think about, like, let's say a React application, calling 10 microservices, it's gonna have to make 10 calls, know what all those URLs are, and get back the results. Having an API gateway in the middle can basically pull all those together and send that down as one response. So it helps in that way. There's some of the other features too, like routing. What's really nice about having an API gateway there is the front end doesn't even need to know the implementation. So you may have your whole API as one, app solution essentially running out there, or it may be 20 different ones. But from the API gateway, it makes it all one nice, neat route. My app /API /account service. And it will actually route it to the right microservice, Azure function, whatever that might be, to put it there. There's some other things that the API gateway can do to help keep the microservices from having to do a lot of the work. Again, we want our microservices to be kind of is focused on solving the business problem instead of technical ones. So instead of worrying about like maybe the authorization or some of the access restrictions, we can handle all that here on the API gateway. And then essentially if it passes authorization there, it can talk to those backend ones. And then also too, like SSL termination, there's a lot it can basically from there on. It doesn't necessarily have to do HTTPS. You could do HTTP traffic between it. So if anybody has questions, feel free to jump in. I want it to be as interactive there too. Yeah, sure.
Gateway, is it the pattern is always used on applications where the front end is there and then you have a lot of API microservices and use fit the API gateway in between? Are there any other scenarios where this could be implemented, such as probably another API trying to access the endpoints on API gateway?
Yeah. So it's. So let me see if I answer your question appropriate. But yeah, there's some of the other scenarios of using an API gateway. You might use it for an API calling to another API, because it can basically be rerouted back through the gateway to find that, and that's a good way to handle the service discovery. We've done that quite a bit. It feels like it's an extra hop and more work, but actually a lot of times these API gateways have caching and kind of that built into it, so it actually speeds up the request, if you will, there. And then what's nice, again, you don't have to worry about the implementation on that. I'm trying to think of other times. I mean, sometimes it's not even just multiple APIs. There's a lot of times, like, instead of having like an API or a URL for your API, like api.myapp.com versus www.myapp.com, then you have to worry about cores and making sure that your application can call those services. So to kind of get not around that, but I always like to try to make it just one nice neat URL, like myapp.com/API. And then a lot of times my API gateway will just do those two different routes. One route to, /star goes to the website, /API star goes to the API. And that might be one, or that might be a number of them. Does that kind of help? Yeah, sure.
And so, Doug, will you explain some of the technologies for these patterns?
Yeah, I'm actually going to show you the implementation in just a minute. So, yeah, and there's a lot of different ways and a lot of different tools. We're doing one for a client, and what even made it more difficult is each tool kind of covers different parts of that. So some tools might just do the API gateway, some might do API gateway, the service discovery, the like web application firewall, like more, so then it's like, okay, well, which combination of the tools did we want? And I'll show you what we basically chose for a project here in just a minute. So yeah, great question. Kind of on the same line as that API gateway, you typically don't have both of these at the same time. I think my diagram did just to kind of show that. But a lot of times, again, with that API gateway, instead of having one service that can basically manage all your clients, and now you're kind of coupled it. Like let's say you have one team working on the mobile app and another team working on the website. Even though a lot of that stuff is similar, you might not want to build a bottleneck here on your gateway layer. So you can actually do what's called a back end for front end and actually do a different implementation for each of those. And a lot of times it's not even just based on the platform, maybe it's built on the application. So I might have 20 services kind of doing a la carte on the different my front ends might be using, one front end might use 10 of them, the other front end might use 5 different ones or similar there. You can basically just make your front end leverage that for the different sides of the back end. So again, this is all kind of about decoupling and not sharing as much from an implementation standpoint. Cool. All right. Actually, I had some notes on there, I guess. So really, a lot of times different clients need different data. So sometimes you try, and this is always a constant battle I think we always fight, right? Reuse versus, barely sufficient or, getting things done. I usually like to go with the idea of let's discover the reuse instead of trying to think ahead of all the ways we can do a reuse, because half the times when we're trying to think ahead of the different ways to reuse, they don't even actually come to fruition. And then we spend all this extra time kind of gold plating, if you will, or what have you. So I think this is a good way to right size what you need and not try to make one API gateway that can do everything. Because then you just, now it makes it harder to test and things like that. All right, so the other one was resiliency that I wanted to touch on. There's kind of different levels. And the interesting thing is resiliency is not about preventing outages, because it is about preventing outages. It's not preventing failures, right? Because no matter what, there's gonna be failures. There's gonna be a NIC card that goes out, a hard drive somewhere, even if you're in the cloud, it's gonna go out somewhere. But the key is not preventing the failure, but if that failure happens, keeping an outage from happening or data loss from happening. So that's really the idea of resiliency. I was kind of, a few years ago, I was like, yeah, that does make sense. So there's kind of 2 levels. At the application level, there's a lot of ways to make your application more resilient. Having that, that gateway or that experience API kind of in the middle, one of the things you can do is actually degrade the functionality. So it may call 5 microservices, but maybe what if only 4 of them come back with information? The 5th one times out or the 5th one's not available. Do you just crash and give a 500 error back to the client? No, you try to make that come back with a response, but maybe the website has like a piece of the website that's not working or can display maybe some cached information from 5 minutes ago when it tried to call it. So degrading that's a really important piece there. The other piece is there's some patterns out there and tools. Poly is the .NET library out there, which is really cool if you've never used it. It actually has the ability to, with like the HTTP client, to do retries and follow things like a circuit breaker pattern. If you're not familiar with the circuit breaker pattern, one of the downsides to retrying is if you're trying to retry on something that's broken, you're just putting more pressure on that thing that's already broken, right? You're just constantly trying to do it, and you're really a lot of times making the problem worse. If it's something that has to catch up, it's never gonna be able to catch up if everything's retrying at the same time. So the circuit breaker is kind of nice because it detects, oh, it's not working. I'm gonna hold everything, and it's always the opposite, I think. Close the, or open it, right? You think of the electrical thing. You open the circuit breaker, maybe you retry 5 minutes and then retry 10 minutes, 20 minutes. And then once it works, circuit breaker is closed. and then everything can travel through there. So again, those patterns there, and there's nice libraries, Poly. Some of that's baked into the HTTP client, but there's the library is actually really nice there. That's kind of at the application level. If you're talking about more at the infrastructure level, we haven't got into AKS too much yet. We'll jump into that here in just a minute, but there's a lot you can do around it, like load balancing across the different pieces. In Azure, there's something called availability zones, which is basically every data center is made up of 2 or 3 or more buildings. And so if one building gets hit by lightning and you're on an availability zone, it's no problem because it's still available on those other buildings. And then if you're worried about total region outages, there's things like disaster recovery. One of the things mentioned earlier was some of the cross-cutting concerns. There's a really cool tool out there called Dapper. It's made by Microsoft, and what it does is it handles a lot of these different cross-cutting concerns, or really developer concerns, and you can leverage them in your code. It actually gets implemented as what's called a sidecar. I'll talk a little bit about that coming up, but I'd say probably the couple of them that are really nice is like service-to-service invocation, so it'll actually help you with some of that service discovery. I can just say, go call account service, and it has account service registered, so it knows how to go find it. If you want to implement state management, but you might want Redis in one environment, or you might want SQL. This is an abstraction layer across all those, and that's really where this comes into play. You're not actually implementing any of these things. It's actually handling it for you, and then it does have some nice distributed tracing, really at the application level across that. So can't really get into it too much tonight with time, but this would be a pretty cool topic on its own, I think. Talk about, I don't know, have you guys ever had a talk on Dapper?
I don't think we have. It's been mentioned a few times, but I don't think we've had a proper Dapper talk.
Yeah, so I think it's GA now, and it's definitely a lot of cool functionality that it can do. They took the best of Service Fabric and put it here. So, all right, so now let's get into the AKS, all right? So our topic was, talking about microservices in AKS. So real quick, because I want to get into more of the demo stuff. If you're not familiar with Kubernetes or AKS in general, Kubernetes is really made up of several different kind of constructs, if you will. The cluster is kind of the whole entire thing. Each cluster is made up of multiple nodes, which think about that as it's a one-to-one for your VM, kind of behind the scenes. And then a pod is kind of your logical representation of your application, or a part of your application. And the interesting thing is they actually made it so the pod is actually one or more containers. You can see over here in this node, it's just one. But you can actually have multiple containers in here. What's really nice is they share the same, like HTTP, they share the same machines. You can actually call like local host on one container and get to the other container. And that's where that sidecar kind of idea comes into play. And we talk about like Dapper, and there's some service meshes and other tools out there. My application might be on this one, and there might be a sidecar container for like Dapper, let's say, here, and I can basically just make a call and it'll intercept it and then do what it needs to do. So that's how you can basically use tools like Dapper and get all those if you think about those boxes that went across there, you get all those for free just because Dapper has the implementation on there. So it's pretty nice. It's all done through HTTP, so even if you're using a language that doesn't support it, you can still call it Dapper. Yeah?
So what's the benefit of having the two containers in a pod? Like, is it faster? The communication is faster, or like what are some of the use cases?
No, so yeah, that's a good point. Your pod is really your unit of deployment. So my application is that. The only time you'd really have more than one container in a pod is if you're using one of those different patterns like a sidecar. So my code's here. I can use some basically common functionality like the Dapper or Istio or like those service meshes. Those will just live side by side with it. And then this acts like one. So it's like a symbiont relationship, if you will, with it. You normally wouldn't like deploy your application twice in the same pod. It would be this case here, you would say, I want it to be done with 2 pods and to get some extra speed and that type of thing. And then you'd load balance across those.
Docker images are separated too, the Docker files.
Yeah, it's
You
good.
have to kind of make a hybrid of them.
Yep, yeah, that's a good point too. So yep, so that's kind of that there. So that's the pods. The deployments are how you want to basically deploy it. Replica set is how many pods you want at any given time. Your services is how it's kind of exposed, either internal or public with like load facing. And then a namespace is a way you can kind of logically group your pods based on maybe like a product or environment if you want to. Think of it like a tag or scope. So I've been mentioning AKS, and AKS is an implementation of Kubernetes, but it's managed by Microsoft, so we don't have to actually install the servers, do any of the patching. Well, we still may have to tell it to do a patching, but you don't have to actually do the patching itself. And the nice thing is it's made up of two parts. There's the control plane, which think about it as like your API or scheduler, and then what you actually want to run all your workloads. And that's I guess the workload, I can't think of it, are just the nodes, I guess, to run your workloads. But what's nice is with AKS, you don't pay for the control plane, you only pay for your workloads, what you want to do there. So there's a lot of options with it there, but that's the kind of the makeup of it. We'll kind of show that. Here, or like to your point of like what the different tools for that is, this is an implementation I'm working on right now. With AKS. This is hopefully the worst case scenario. It's kind of a fully private cloud or private implementation. So with this, what we had to do was we had to make AKS private. And then so we needed a way to still get to it from our end users. Typically we'd come in through a public IP address. In this case, we're using an application gateway to front the application. And then it's doing that gateway, like I mentioned about the API. I'm actually routing all the web traffic to the private end or to a static web app. And then all the API traffic is going to the Nginx ingress controller, which then gives me like a single entry point for all my pods on there. There's a few other services we have down here, including like a container registry. All these things are private. One of the kind of special requirements is they want everything to go through an Azure firewall, both incoming and outgoing. So we can't use this public IP address. They're actually having this stuff come in here to our private IP address of the application gateway. And then I put an Azure front door in front of that right now. It's like, really, we got to put a front door and an application gateway? But the problem is if I don't put an application gateway here, as soon as the client hits this VNet that's all the dotted lines here are the VNets. As soon as I hit the VNet, I lose my client's IP address. So I need front door to put it in as an X-Forward4 header, so then I can do tracing and debugging down there, if you will. So let's look at what this looks like in the portal here. And then go from there. So let's see. All right, so this is my Azure subscription. The main thing I wanted to show was, well, actually, let's start with the application gateway. And I'm not going to go through everything, but the application gateway is really nice if you've never used that in Azure. It can basically front the application and allow you to do things like, well, it has a web application firewall in there, and it can route your traffic. So what we've set up is essentially two backend pools, and the backend pools are really where we're going with our applications. So we have a default app pool, which you see will go to our static website, and this is the Azure Static Web App, if you've seen that service out there. And then the other backend is the IP address of my ingress controller. And so how we have that managed is we come down here to our rules, and we say if anything comes through the normal path, or basically, actually we'll say it this way, if anything comes back an API/star, it's going to go to our ingress controller. Otherwise, it just goes to our website, and that's the other backend pool there. And so the backend or the website is essentially that static web app. Let's see here, I don't have that. This is a kind of a newer service for maintaining that. And then this is the application. I guess there's probably not a lot to see other than the funny dynamic URL it creates with every deployment. And then we have the backend API, so I can come out here to my Kubernetes cluster. And then from here, there's a couple of settings. One, it's, where's that? It's set to, yeah, it's private cluster is enabled. So really nothing of this is public. You can see I have, well, here I'll come out to my workloads. Oh yeah. So it's private, so I can't get to it. So I have to go out to I have a jump box essentially. And maybe my farm credit connection won't let me get to that. That's all right.
Hashtag security.
What's that?
Hashtag security.
Hashtag security, yes. There's no getting around their security there. So yeah, so with AKS though, we can actually see what the workloads we have deployed, the different namespaces like I mentioned that represent the different applications we may have deployed. We can see the service and the ingresses here. Won't actually be able to show you the actual service and ingress here. But if we go to our browser, if everything is still working, let me bring up Chrome. A few profiles there. And then if we come up and do, I didn't install a search here, but myserv, and you can see if I bring up the plain URL, this should bring up, what does it get, Sean? Hashtag secure.
Yeah.
So this is a domain I registered, so I'm pretty sure that's why it didn't like it there.
Get a mobile hotspot.
And Sean has seen my code in production, so he knows it's sketchy. So yeah, so I guess if we were looking at it, we'd see that we could see the website and then we'd see the API. So I guess any questions on that or anything? I know that I didn't get to show everything because of some of the security stuff, but better to be safe than sorry, right?
The application gateway, how much does that end up running
Cost-wise? So if you run it with the WAF and V2, it's around, I think it's like $150 per instance. And so like in prod, you'd want to run 2 just from a high availability, and then dev and test or whatever, you'd run the same thing there.
And then it looked like as you were configuring it, that they basically both had the same domain name. So you kind of sidestepped any cores issues too.
Yeah, exactly. Because that's the whole idea. Is like what I was trying to show in the URL was, if I just went to the URL/nothing, it would give me the static web app. And then if I did /API, it would redirect it to my AKS cluster through the ingress control, and then you'd actually see the API that I have out there. And then, then I don't have anything cores. And that's what I usually try to do. And even if I'm using like Azure Function, they'll use that proxy, the proxy to do that. But yeah, just to kind of avoid any cores. I don't know, just always feels cleaner, which is.
Cores is manageable, but it's always one of those things that you seem to stumble on.
Exactly, yeah. Yep. Yeah, no, great question. Any other questions at all about any of the pieces? The Azure Front Door offers a lot with the gateway, and it's a lot cheaper too. You can get it to like $50 or $60 a month. The more route, you get charged per route with this, so it can get more expensive, but it's kind of nice because you have a lot more granular control.
Front Door also provides certs for your site if you want.
What's that?
Certificates, you can take certs.
Yeah.
I think that's what I'm thinking. What's the difference between application gateway and front door? One is certs, and I don't know what other differences are.
You can do certs in both.
Okay.
Yeah, and both of them, I mean, I could have used the, and actually I could still do this, is the front door has both its, azurefd.net or whatever the URL is. I could access the site through that to get to it.
The front door you're.
What's that? Yeah, front door I could do that with there, or I could do that through the public IP address here of my application gateway and get it through with using the app gateway has its own URL with an HTTP or with a client cert.
I think front door does global traffic balancing as well.
So-
App gateway, you have front it with the traffic manager for region.
Right, yeah, so app gateway is regional. So yeah, you typically use traffic manager to route the traffic globally. And then yeah, Azure Front Door is global, which is one of the reasons because you had to use app gateway here is because it was, since I'm already on the private VNet, it needed to be regional. Front Door does support private endpoints, but it's still in beta, or in preview, I mean. Yeah, any other? All right, so let's kind of last part I wanted to talk about here was the pipelines. So kind of what's represented here, it's a little bit different, I'd say, than traditional pipelines. I'm just gonna advance this there. Is with this, the pipeline is more of a pool. And so instead of pushing from, my batteries are about dead here. Yeah, instead of pushing from Azure pipelines to Kubernetes, I'm basically just deploying some config files, and then the orchestration service inside of AKS will say, okay, it's time to go install this now, and then it'll go pull the images and spin those up based on how we want this deployed and how we want this configured as a service. So these are basically called manifests or Helm charts to describe how you want your application to run in AKS. So that's where it's a little bit different than, I'd say, a lot of our deployments where we're just pushing to the Azure core services there. So let's, here with the last demo, I believe that's the next one, is I'm just gonna show what that looks like here. So, of course, jotted down a couple of quick notes on that demo here. All right, let's see how we'll start with the repo. So let me, so this is just an Azure DevOps instant here within, oops. Within this, I have my weather API. And so this is basically just a .NET Web API service, very basic service here. But one of the key things I have is this YAML file in here. This YAML file don't have my mouse, so it's hard to remember the shortcuts to zoom in. All right, so yeah, just a couple of the or what we could do in here. There's really two parts of this. I remember for showing it, there's the deployment side of this, and then there's the service. The deployment will really tell how many services I want out there they might have. And then the service here is basically how we want this exposed. So there's like cluster IP, which is really just private, and then there's load balancer, which is like a public one, and there's a couple other ones that are represented out there. But this is essentially how we want that service represented, and then we have the ingress to basically map to this one. And of course, it's on that VM that I can't get to. I'm trying to think, I don't think that's here. No, I don't have it there. So that's kind of the API. Let me show you the pipeline. Guess the last one failed. So I'm basically using the YAML pipelines with this from a different stages. Oh, that's right. I was letting somebody else use this. Or no, not this one. Never mind. Yeah, so on the build side of this, we're essentially building out the application. Don't remember why I commented all this out, but just following like the typical .NET Core, we're building out the service. Then we're calling a Docker task to essentially do the build and push. So this will build our Docker file, and then it will push to our private repository. Here's that, or registry, there's the connection. It's going to take my YAML file, copy it to my pipeline artifact, and then from here, this is actually one of the things to kind of note is this is actually running on a hosted agent from Microsoft. So this is just an image that Microsoft provides, or an agent. And so I'm doing all the building there, but then when I'm actually deploying this, I actually have to deploy it from inside my cluster because everything is private, including the API to tell AKS to do an install. So I actually have a self-hosted agent pool running in there in my cluster to actually deploy the application from that. So this step is actually doing the deploy from within there, and you can see creating a secret, and then to the between my ACR or my Kubernetes, or I'm sorry, the container registry and the Kubernetes service. And then I'm actually deploying and telling it basically to use that manifest to then deploy this container here. And so that will actually deploy, and using this tag to basically represent like the latest build. So I'll always take the latest one when I'm deploying it there. And so kicking this off then will essentially tell AKS to go update the pod and then deploy. Unfortunately, I can't show you that because Sean, no, I'm just no, because of security, which makes sense. So yeah, so that really deploys it. I'm trying to think if there's something else I wanted to show with that, but I think that is the most of it. The static website, I guess I could show that deployment, but that's not really a microservice. The static web app, just really simple because I just have source files out there. It's just deploying with the static web app task and then taking the files. I don't have an API, so there's nothing to deploy to that. And then the token is something you register from Azure to allow to deploy. So that's pretty simple there to deploy to that from an environment's perspective. Any questions on the pipeline?
So if you had Helm charts, where would that go?
Yeah, so it would just be a different task. In so I would just in my deployment, my deploy stage, instead of calling the Kubernetes manifest, I would just call it Helm task. Then you'd specify the Helm chart, and then it would essentially do the same thing. Any other? All right, let me switch back to this. I think that's really wrapping it up there. I did include a few links to some of the stuff that I had. There's some actually pretty good hands-on labs out there for getting kind of familiar with Kubernetes and then even deploying Kubernetes from a pipeline. Any other questions?
I had one more.
Yeah, no, you can keep asking.
On the database side, like when you're designing microservices, what's the approach that you take when we have a server which is capable of maybe hosting multiple databases and then multiple microservices using it? Generally, that becomes a bottleneck. When a particular microservice grows in size and usages, basically, it kind of affects the other microservice.
Yep.
Actually using the same resource. these are some of the practical things that I see, so I was just wondering, like,
Yeah, no, that's,
how do you tackle with that situation? Because we cannot provide one server for a particular microservice, right?
or could you? So I'd say one of the things I really like about, one is the cloud, and looking at it from a microservices and even DevOps perspective, is on-prem, we used to do things like, we'd create one SQL cluster, and it was really expensive, so we needed a lot of people to use it to kind of cover the cost. What we can do in Azure is you can basically provision the infrastructure in Azure to really be application-centric. And so really for my microservice, I can deploy just a single Azure SQL PaaS service, the server and database, just for the size I need for that application. I can do Cosmos if I wanted to do like a NoSQL implementation for just that one. And included in that, I didn't really show the some of the infrastructure as code, but what we would do is we would deploy the infrastructure as code for the SQL Server along with that microservices pipeline. So in my example, like the web API, like let's say we're pulling the weather from a database. So we'd have the ARM template for the SQL Server PaaS database. We would deploy that first and then deploy the application, with the Kubernetes step that I showed you. And then it would be kind of self-contained there. So any changes I needed to make for that weather API, whether it's code changes or database changes, it all goes through just that one pipeline, and it's all self-contained. So I would say, because SQL PaaS can be configured all the way down to like $15 per, the server doesn't cost you anything. It's only the database is what you pay for. And so you can do that and then have your, essentially your infrastructure completely independent for that microservice than anything out there. Obviously, AKS is going to be shared across your microservices, but that again kind of goes back to that original thing. If you just have a couple services there, AKS is going to be overkill. You just deploy it to some PaaS services. But if you have lots of services, that's where that kind of that scale starts to lend to that shared infrastructure for AKS. But otherwise, we try to keep everything application-centric and just at that level. So I would say you just deploy a database for that service and keep that independent than anything else.
Have a server for it.
Yep, yeah, you have I'd have a weather SQL server and a weather database, and it'd all be deployed independently, and then I don't have to worry. And what's really nice then is like, you got these change control boards and things like that. If like anybody else deploying the same night, you don't even have to worry about that because like all your infrastructure is just your infrastructure. So.
Okay. Have a very difficult time convincing DevOps that.
Oh yeah, convincing which team? The DevOps?
DevOps.
Really? Because that would, to me, that's the whole beauty. Like DevOps is hard to do without that. Otherwise, if you have to have shared infrastructure and trying to do DevOps, you're never going to fully achieve, I think, what you're trying to do. And so that's where application-centric infrastructure is one of the keys to that.
What if data is also independent? Suppose if data is with the core database or something, maybe we need to figure out ETLs to get the subset of that microservice data.
Yeah, so you might think of the microservice data as kind of an independent, or not independent, but an intermediate kind of data store, and then you might have some sort of offline processing to put it off to like a data warehouse or some more permanent location or some sort of process there. So yeah, that's definitely a common use case for that. But you wouldn't want your microservice bogged down with that process. That would be some sort of like, event grid, service bus, picking up, every change, it would see that and then it would go pick it up and do something with that to move it wherever it might be. So it'd be more of a on the fly or as you go type of ETL process instead of like a batch. You wouldn't want to do batch. You'd want to try to do that real time.
So to get your project stable, if you're setting up again for another project, is there any pain points or notes to yourself, that were a little more challenging to get set up and get working properly, or did it go pretty smoothly?
You mean like the big picture I had up there?
Well, maybe just more on the AKS side of it, maybe not so much the...
So the private part of it it was a huge pain. Like it was way harder. Like I've done public ones and it's like, you can spin it up and get it out there pretty quickly. But trying to create that private one and get everything working and everything private so it's not like exposed, and then also using like Azure Firewall to basically route all the traffic through. They basically wanted all egress to go through the firewall. And so the Azure Firewall is basically an opt-in model. Everything is blocked by or denied by default. And so you have to figure out like all the exceptions. So figuring out like, even like when you are spinning up the like AKS, it has to like, for those nodes, there are VMs behind the scenes. Like it has to have access to the Microsoft Container Registry to pull some of the services down for AKS to run. So there's a lot of those types of things. So there's definitely, I would say, a lot of gotchas when you go to like try to do it with the private, but public wise, I don't think there's too many. But I would say there's different options for the ingress controller. We initially tried the application gateway ingress controller. It's kind of built in from, it's basically an add-in for AKS. And then it's a checkbox essentially to enable it, but we just ran into too many weird things with that. So that's why we went to Nginx from an ingress controller, more of a traditional Kubernetes controller. The downside is it consumes some of your AKS resources or Kubernetes resources because it actually runs as a container in your cluster, whereas the app gateway one didn't. So that was kind of nice. And then but it just did some other weird stuff. So, so I think that was one of the probably learnings that we did. I think again, firewall that one was one of the more challenging pieces. And then some of the gotchas of just getting like so we're getting it set up with like the Azure AD and like the using managed identity from a pod security perspective. That there's some challenges to getting that running, and it took quite a few tries on that one. So I definitely have been keeping a log of like everything I've done and figured out and errors and what I did to fix them. Because there's definitely, getting that whole diagram to work has been a lot more work than I thought it was going to be. So, yeah.
Kind of sounded like when you were talking your data that you were mostly stateless in Kubernetes cluster and everything, all your state was basically stored off.
That's a very good way of saying that. Yep, absolutely. Yeah. So we try to keep everything stateless, and also, because we don't control when pods get spun up and spun down, and the nodes maybe get reset, or maybe maybe you have your AKS cluster set to do maintenance and stuff like that. So you don't really know when that's all going to happen. So you have to really be thinking about that from a persistence standpoint. So yeah, good point.
Is there any way with AKS to track costs down to an application level? Or are you just kind of looking at the one big pool of AKS spend?
So you can set up different, you could set up different nodes to represent different areas. I don't know if you can do the cost per anything within the nodes. Like you could probably do the namespaces. So if you set up the different namespaces within AKS, you could probably get the cost per namespace. I haven't tried, but I bet you could. So you'd use that probably to do that. Because you can tag AKS, but you can't really tag the individual resources in there. Yeah, good question. Anything else? Yeah.
So in the portal, for example, for a pod, does it show the memory usage and CPU usage and stuff like that for a particular pod, or do I have to get them and plug in with some kind of use like learning for Grafana?
Yeah, that's a good question. And so they've done a pretty good job with the portal. I wish I could have shown you there on the private piece. But yeah, they do have a lot of that information available when you click on like the pods and stuff to see what the resources are. So you just think of like anything you do like kube controller, kubectl, however you say it, for multiple ways. Like if you do like a describe or just do like the get pods, like that, pretty much that kind of information is available there. There's also other tools like Grafana, is that right? Where you can get some of that information and stuff too, and those can hook right into it. But the portal does a pretty good job of getting some of that information. Like you can get down to like I've been using it for, I feel like I'm not doing it like the native way sometimes when I'm in there, though. Like I'll just like, look at the logs and things like that. And I'm like, yeah, I should probably be doing it via command line with kube control. But it, yeah, you can get to quite a bit of information with it.
Debugging a running application in a, one of the nodes or containers, is that, I know with app service, they have the application insights and those sort of things. Or
Yeah.
SSHing into a running container. Have you had to do much of that at all?
So yeah, you can do a live connection to some of the containers and connect to them to kind of get the logs and things like that. I'm trying to think if it connects well with like the open logging with like Prometheus, and then also App Insights. You can get a lot of that like distributed logging information. The other thing you can do, I know this isn't exactly what you're asking. I haven't actually SSHed into the containers too much, but you can. But one of the other things too is there's what's it called? It's an add-in to VS Code and VS Extension. It's like Kubernetes. I can't think of the name. But essentially what it does is pretty nice. If you're running your part of, let's just say you had like a couple hops of a service or column there, if you're debugging one of those, it will actually go register that local version of yours and redirect traffic to your local server and then redirect it back to like whatever's like downstream from it. So if you're actually doing something in between, it does that. I can't remember the name, but it used to be called, there used to be a server-side version of it. I can't think of the name. I've got it in another slide deck, but I can't think of the name of it. But anyway, there's a nice tool that kind of helps you from like if you think about it, if you're like running like 15 services out there, you don't have to have all 15 services running to kind of step through something to see how it works. You can just start your service, run that Kubernetes to go, and that's not the name of it, but I can't think of the term, bridge, Kubernetes bridge. That's what it is. And then you can just still hit your front end, but it gives you like a different like front end, like a mic.myapp.com. When you come in from that URL, it will route it down to your local host, and then like I said, anything else will go back out to it. So that's pretty cool. But yeah, it's called Kubernetes Bridge, and it's just a plugin for Visual Studio or Visual Studio Code. So
You usually know when it's because you're kind of layered right with services and. Where it appears like, hey, everything's good and deployed, but actually like, something kind of, catastrophic isn't allowing it to run like the actual, inside the pod, the container.
are you saying have I run into that?
Like, have you ever had that case where kind of everything looks healthy, but?
Yeah, absolutely. And then you're just like, why is it not working? And yeah, it is kind of there, and that's where that distributed tracing comes in nice, because you could see kind of where it's, like what part it's failing in, and that could be something where then you're like debugging it locally, and then trying to find out where in that application. But yeah, the distributed tracing is really important there, because you can't, it's not just like a monolith where you can just run it local and find where that error is happening. So a little more challenging there. Yeah, awesome questions. Appreciate it. Anything else? Yeah.
May I stand up?
Sure.
I joined this group a few years ago looking to get some help on an issue that exists today with me. I'm interested in converting a VB6 code to .NET. If there's anybody here tonight that maybe has done that before, can give me some hints on where we're at on those conversions, I'd appreciate talking with you tonight, or I can give you my phone number. Thank you.
Yeah, I know there used to be some tools out there that helped you do that. I was trying to, I
There's a
can't.
company that they would actually do it. They were doing the part of the original conversions that .NET itself will do that conversion for you, but they would actually had some special rules. But otherwise, .NET does most of the conversion itself.
That's new to me.
like a upgrade kind of wizard type thing when you open up the VB6 project.
Right.
Wow, that's cool. I know I've done that with like some of the old like .NET 1.1 or applications that will.
Yeah, it was like, when .NET first came out, so I don't know if that's the current versions of .NET, but it used to be in there for the original version of VB6 to .NET.
Yeah, that'd be cool. Yeah, I'm trying to remember. Yeah, I don't know.
Probably depends on how big and complicated and all that sort of stuff the 86 program is.
Best thing to do is just try to open it up into a .NET and just see what it does. You might just have to do some minor tweaking on it, but.
You stop laughing. Thank you. I'll look into that then. Thank you.
Yeah, sure, absolutely. Yeah. Anybody else have anything? Otherwise, everybody's excited about the gift cards. But yeah, thanks everybody. Appreciate it. And I'll put the slides out there. And if you guys have any questions after, let me know too. Happy to talk more. But yeah, thanks.
Cool.